All right. Good evening and welcome. I know there are a bunch of other talks going on in parallel, many of which I was pretty interested in. So you chose to come to this talk. Thank you very much. I'll try to make the best use of your time. Uh, my name is Kaushik. I am currently a senior Android carrot at Instacart. If you haven't heard, Instacart is an on-demand online grocery service. If you haven't used the app, it's life-changing. From the comforts of your couch, you can order from Whole Foods, Safeway, Fairway, another store here, all from the comfort of your couch. It's amazing. It's life-changing. You'll never leave your couch, so that's amazing. I also started this podcast called Fragmented with my co-host Don Felker, who happens to be here, thankfully. Otherwise, we would have had a very awkward conversation about why he didn't attend this talk. But anyway, he's here, so that's good. Fragmented is a really fun podcast because we interview some of the best developers, many of whom have actually given talks here at Droidcon. Come and say hi. We don't bite, so we love talking to listeners. So after the talk, come and say hi. All right. So it doesn't really matter how fancy your architecture is. It doesn't matter if you use RxJava, Dagger, Retrofit in your application. If in the end your application the UI of your application doesn't necessarily do what it's supposed to do. Because you know what will happen if your UI doesn't work? Users will look at it and bam, 1 star. That is a big problem. So, you know, there's this idiom that says the proof is in the pudding. So the closest the user can get to this pudding in this context is your UI. So if your user interface is so crucial to the success of your application, then you absolutely 100% must test your UI. The problem is testing UIs are kind of painful. They're not that simple. Let me ask, like most big organizations today, if you ask how they actually do their testing, like really, if you take them in the back door and ask them, hey, how do you actually do your testing? All of them will say the same thing. They do it manually. They take their phones out during like the release period and they peck at their phones like animals. We shouldn't be doing manual testing in this day and age because you know it especially like the times of release are like the best times because usually when a change comes up and you're like, okay, I'll fix it and go and talk to my QA person. The QA person will go, well, okay, I'll change. We have changed this part of the application, so okay, we'll test this part. And then they come back with more bugs because the problem is, I mean, you know, we're developers and sometimes we do write crappy code. It's unfortunate, but I mean, it happens. So, and if you want to refactor some huge change in your application, you'll have to go to your QA person and tell them, hey, you know what? I refactored this base activity just a little, so you may want to like retest the whole thing altogether. And trust me, that is not a friendly conversation to have with a QA person, if you're even lucky to have a QA person. Because you see, the point is, human beings suck at repetitive work. Like if you have to keep doing something over and over and again, even if your QA person is kind enough to actually take the trouble of doing those tests repeatedly, after a certain point, their brain is going to go mush. It's going to be really hard even for them to do this. So, and again, it's the whole awkward conversations with like your QA people. So you should go back to your roots. Think like nerds. What do nerds usually do when they have problems with other people? They replace it with machines. So that's what we should be doing. We should be replacing all our actual testing with machines because, you know, unlike human beings, if you go to a machine and tell it to run your test, it'll say, cool. You run it 100 times, 200 times, 300 times. It is absolutely no problem to do that with machines. So if you take this to the world of testing, how does that translate? It translates to automated testing. So automated testing is great. The only problem is you actually have to write the tests. And if you think about UI testing, writing automated UI tests are really hard. Now, the landscape has changed in the last 1 or 2 years. Google has been doing an amazing job with Espresso. But this brings us to the next biggest pet peeve that I have with UI testing, and that is speed. Now, I don't know about you folks, but if my tests take more than 10 seconds to come back with the result, I am out of there. Like, the next thing I know, at second number 11 or 12, I'm on Reddit on one thread saying, like, hey, fragments are the best thing to happen in, like, mankind. And in the other thread, I'm saying fragments suck. Fragments have this problem. Fragments have that problem. And in other threads, I'm probably saying you should all be using enums. Completely non-controversial stuff here. But in any case, UI tests take time to run. Why is that true? Because you see, anytime you make a change, you actually have to cook that change into an APK. That APK is taken, it's shipped to a device, and then you have to have the tests run on the device, right? So by nature of just the process, it takes time. So what can we really do to avoid this problem? Like, are there any suggestions? Yeah, I mean, if running your tests on the device is a problem, then what you should probably be doing is not running them on the device, right? So how do you do that? Now, that gets a little tricky because Android is not natively built to do that. So we have to think about it a little differently. Now you see, instead of actually running your tests on an APK and on the device, what you can do is actually use the JVM. Because you see, the JVM is super straightforward. All you have to do is give it a bunch of Java classes and it'll run the test. And this is wickedly fast. It's much, much faster than running any other tests, any other UI kinds of tests that you have. But like I said, this is a kind of different pattern. Android was not natively built to be able to just run everything on the JVM. The device is an integral part. But it is possible. Now you see, we have to come up with a different pattern altogether to be able to write all our UI tests on the JVM. And there are a whole bunch of patterns that have come up these days. There's MVC, MVP, MVVP, and at a certain point, it gets really confusing. At least it was super confusing to me. So I did what any good engineer would do. If I found that I have a problem, I tried to find another engineer who's just much more smarter than me, who came up with a solution, and I say, this is how everyone should be doing it. So that's also a very good strategy, by the way. And it so happens that there's this gentleman who goes by the name of Martin Fowler, who's actually done all the work for us. He's thought about this in depth, super smart chap, super wicked chap. I mean, I've not actually met him, but I'm sure if I met him, I'll be good friends with him because he's a very smart guy. Now, the thing is, he's actually come up with these huge sort of articles, and he's called it the supervising controller and the passive view patterns. These are amazing patterns, but they were built for enterprise Java applications. So what I sought out to do is sort of like adapt these terminologies, adapt the learnings from what Martin Fowler wrote, and actually try to apply that on Android. Because if you could potentially do that, that makes life in the UI testing world really simple. But instead of actually explaining these terms, there are three fundamental terms. There's the controller, there's the view interface, and then there's the presenter. But instead of actually explaining this in words, let's try to do this in a more visual pattern. So you have a phone, and then you have a screen. As a developer, what is the first level of interaction that you have with the screen? It's the activity, right? So you have an activity. Now the problem is, we set out with the objective of immediately trying to move away from the device and onto the JVM as fast as possible. So let's first try to do that with this object called a controller. Now, a controller is just a simple purger. I'm just calling it a controller. You could call it anything. The reason I call it a controller is because Martin Fowler calls it a controller, and at a certain point, it's good if we all just share the same terminology. So a controller is what we're going to call it now. It's a simple, plain old Java object. And the only role for the controller is to immediately take the actions that you get from the activity. So the minute you get any event that's on your activity that's come in from the user by actually changing the interface, so for example, like an on-text change, immediately just ship it off to the controller. So the controller is the first level that on the JVM tier that actually takes in all these actions. So that's like a good sort of, that's a good yardstick to have. Like if you want to try to understand, okay, what kind of actions go into the controller, it's pretty simple. Anything that comes off to the activity, immediately ship it off to the controller. That's the first thing. Now, you could potentially run all your actions, do all your processing inside the controller itself, but the problem is you'll violate this other big pattern that's called a God object pattern, right? You don't want to have God objects. And it makes no sense. If you're just simply plucking out all the logic from your activity and just like planting it into this object called a controller, you're not really gaining too much. So what you want to do is actually create another object, create a bunch of these satellite objects, and delegate all the functionality that need to be done into these satellite objects. So from the controller, what you do is you create this object called a presenter. Now, what exactly is a presenter? Because again, many of these terms are interchangeably used in many of these patterns. So I'll try to be as clear in my understanding of these objects. So a presenter is this, again, another POJO. It's important that all of these are POJOs, which are plain old Java objects. A presenter is this simple object that tells the controller, hey, I gotcha. All you have to do is just give me the ingredients. So give me the raw ingredients. I'll cook the output in the way that you want, and I'll give you a nice, well-prepared meal, or so to speak. So the controller doesn't necessarily have to worry about this. It's the presenter's job to sort of take in all these ingredients. So in this case, if you have like an on-text change, the text is essentially the ingredient, because what's the text that changed, right? So you have this text, you ship it off to the presenter. The presenter takes this, does a whole bunch of things depending on like what your logic needs, what your logic has to do, and it ships this ready-made meal and gives it back to the controller. Okay, great. So you're at this point where you have a controller, it takes in the actions, it gives it to the satellite objects to prepare the output in a way that you want. What does the controller do? It has this nice, freshly prepared meal. You want to ship it off back to the activity. But here's where things get a little interesting. You have the controller taking in actions, and you want to give the action back to the activity, because in the end, it has to go back to the activity. The activity is the first level of interaction. What do? You could technically pass a reference of the activity inside the controller itself and maybe use that. The problem is we want to stick to the JVM tier. There's a huge advantage in sticking to the JVM tier. So Java has this trick that has been used for time immemorial, and it's just called interfaces. So anytime you want to decouple a sort of link between two objects, between two sort of like levels, you use something as simple as an interface. Now, I call it a view interface because technically it's the way that you ship things back to the view. A view interface is just a simple interface. It's like the traditional Java interface, and you have a couple of methods defined in that interface. Every time you create the controller, you also pass in a view interface. Now, a view interface could be any object. Any object that implements this view interface is allowed to be passed in at the time of creating this controller. And this is important because when you run your actual application, what you could do is you can make your activity implement this interface. So that's accepted when you run your application. But when you're actually testing, you could create any object. You just pass in a mock that implements these three methods, and boom, you're off to the races. You can send it in, it'll receive the methods. You could do anything that you potentially want. But in the context of what you're testing, it may not really be important. So this is a huge advantage. The controller gets in this freshly prepared meal. It passes it to this view interface. And in your application, basically, it's the activity that implements the view interface. So this is traditionally at an overall high level. This is the gist of it. Now, there are certain intricacies in the same pattern, but for the purpose of this talk, we're going to try to just think of everything in these sort of aspects. Now, I told you there are many satellite objects because you can come up with the question, well, this is great if all you're doing is just like not reaching out. Well, what if you have to have network requests? Network requests is almost like a given in any application. Database queries, if you want to like query a database, obviously this is also something that you would need to do. Just create these service objects. Now, these could also be POJOs. These could also be just plain old Java objects. Have these sort of service objects perform the actions for you. So if you have to retrieve a list of actions, create a service object. And they're going to be talking about another example, like a login example, just like so that we can get all these, grasp all these terms. And you'll see we can use another network service in this aspect. So since we're talking about the login form, let's just quickly try to run through the exact classes that I would create in this hypothetical login example. So you have a screen, you have a username, password, and you have a login button. Okay, I'm just making sure the same things are showing there. Okay, you have a username, password, a login button. The first level of interaction is obviously the activity. So let's call it a login activity. Now, I personally don't have anything against fragments, so I would use a login fragment, but well, to each his own, or her own. So you have a login activity, and inside this login activity, you would have an on-click listener. So if you're using Butterknife or you're using any of these on-click listeners, you have an on-click action inside this activity. Now, as I said, immediately any action that comes in, you want to ship it off to this object called a controller, which basically accepts all these input actions. So you have a controller. I would just call it a login controller. So a login controller.java would be the name of this class. Inside this login controller, I would have a method saying on login button clicked, and I would actually pass in the username and password. So if you try to think back at how we thought about this controller and presenter pattern, we are at the stage where, okay, we have sent the actions immediately to this controller. Now this controller has the ingredients. What should it really do with this ingredient? Typically in a login example, you would maybe want to use a network service or like an authentication service in your background to actually run this. So just in this case, we would create something called like an auth service, and this could be a network implementation, it could be anything. But in the context of your tests, it really doesn't matter, because when you're actually doing testing, even on your device, there's no way you're going to be testing your server. You're hopefully doing that independently. That's not a part of your testing as an app developer. So you have an auth service object. Inside this, you have two methods like check username, check password. You could have any bunch of things. From the login controller, you ship it to the service object. The service object sends back results. And assuming the results that come back from your network service is like a code, like an HTTP status code or an error code for that matter, these are again ingredients. So what does a controller do with these ingredients? It ships it off to this independent object called a presenter. And I would just call it a login presenter in this case. Assuming you have an error code, just pass this code to the presenter. The presenter says, okay, if you see this code, then this is the action that you're supposed to be taking. So if you have an error code, you would send it to the presenter. The presenter would say, hey, for this error code, you should probably be showing this error message, right? So what do you do at this point? You want to ship something back from the controller. You've gotten all your results at the controller, but you want to ship it from the controller back to your activity or your login activity, right? So this is where the whole view interface comes in. I would create a view interface with two methods. It could be show error, and you could actually show the error message which the presenter gives back, or you could actually have a move to welcome screen, because I mean your authentication service doesn't necessarily have to always fail. That would not be too good. So if it is a success, you would basically pass it back in and call this method, say move to welcome string. So where would these? So we have this interface, and here's an interesting thing. So in the world of C#, there's basically, I haven't developed in C#, so I don't necessarily know the terminologies, but usually there are prefixes called, you have to have an interface with the prefix I. And I listened to another podcast in which there was this Ruby developer called Cody Haynes, and he mentioned this trick. Whenever you have interfaces with the prefix I, think of it as the English article I. So what does this interface really do? Because you don't want to create, like you have a controller, you have a presenter, you could have another very technical sounding name, but instead of that, like, why not just use something that it actually does? So in this case, what does the interface do? The interface just talks to the login screen. That is the only purpose of this interface. So I actually name it I talk to login screen, because this object, technically the only role of this object is to talk to the login screen based on the inputs that's given. So that's why in this example I've used I talk to login screen as the implementation. So from the controller, you have this instance, you have this object that's implemented this interface. And based on the message that you get from the presenter, you just ship it back and say like either show error or move to welcome screen. So it's, once you think about these as sort of individual components, it becomes pretty easy to reason about all these things. So the implements I talk to login screen, this is again just a very simple sort of implementation inside your activity. The show error method has a set text. And it's important to point this out because, again, a lot of this is sort of judicious testing, right? Now, I am of the opinion that if you have a text view and you actually pass a message to the text view and actually set the message on the text view, you don't really need to test if the text view really did that. Google does that for you. In terms of libraries, any library that you use, you don't necessarily have to test that the library does what it's meant to do, because that is the role of the developer. That's the role of people like Google in their SDK. Don't test the SDK, don't test libraries. Test the stuff that you change. So if you have individually made sure that these components work well, if you have made sure that your presenter gives you the right output regardless, then it makes it pretty straightforward. Now, in the part of the conclusion, we'll get to certain aspects as whether you, okay, so does that mean you don't need espresso tests? I'm not necessarily saying that, but we'll get to that in the conclusion. But if you are able to individually test these components really well enough, then that sort of makes it really easy because you don't have to worry about like these other external dependencies. Okay, so this is essentially, you have the login controller, it ships it to the interface, it goes back to the activity, and you've completed this whole chain, so to speak. Again, all of this on the right hand side is JVM testable. Let me do that again. Okay. Everything on the right hand side is JVM testable, and because it's JVM testable, you can run wickedly fast tests on these, and it's super fast. You don't have to worry about like the APK being built, shipping this on the APK. All that is not a problem. Everything just gets done at the JVM level. So what does an example test really look like in this case? So this is, I've done semi-pseudocode, and I actually have a GitHub repository, not for this login example specifically, but I actually have this GitHub repository that I'll share with you towards the end, where I've actually implemented some of these real-world things. So it'll make it easy. Now that I'm explaining these concepts, you can sort of understand the terminology, and makes it much more easier to parse that GitHub repository. So this is an example test just for the login, for this whole login functionality. You create your controller because as soon as in your activity, you need to pass it into the login controller. So inside my test, this is me UI testing at the JVM level. So all of this runs super fast. I have a controller, I create the new login controller, and remember we have this interface that needs to be provided. So I'm providing this talk to login screen mock. In my test, this is just a mock object. So I can implement this mock object, and I can say, if this method is called on it, do something else. And I usually prefer Mockito as my my library, my preference of mocking, because it works really well. Okay, so I have controller, and on login button clicked, I pass in a username, I pass in a password. In this case, I'm hoping that my, this is a pretty weak password, and assuming you have certain logic that controls how strong or weak your password is, this would make sure that you have an error message saying, are you asking to get hacked, or something along those lines. A similar test, so here's another important thing. Google recently allowed you to sort of run unit tests in your Android package itself, and this is a huge advantage because assuming you have localization, so if you have like a whole bunch of text for different localizations, you can actually, this is, I wouldn't call it a hack, but this is like an interesting sort of way of looking at it. In your actual test, you could use the string ID as a reference, because in the end, what you really care about is that r.string.error message is what's being used. So if you actually use this, it'll be an integer ID reference. And so inside your test, you could actually use this. So that removes a whole bunch of concerns that you might have about localization. So like, well, okay, what if it's not English? What if it's a different language? What if it's Spanish or something? All those are sort of like made much easier because you can actually use these resource references when you run tests at the JVM level. Okay, so this is another example because again, you don't want this to always fail. So if you want to pass in maybe a stronger password and you verify that move to welcome screen was called in this alternative case. All right, so we talked about this hypothetical login example. I want to quickly try to show you. So I created this application called Remy, and I was hoping this application would eventually make me $1 million, and that would let me go indie and I don't have to work anymore. But because this is like a cutting edge sort of application, and if you ask me what the application is, it's a to-do application, right? So to-do applications I've heard are great, and you can make $1 million out of these. So I said, hey, let me start out with this. This is going to be a little tricky because I guess I got to turn a little. So okay, so this, I've basically been using this to-do application for the last 6 months. But Dan Liu in his talk actually yesterday said, well, you shouldn't talk about anything if you don't really use it. So luckily for me, in the last 2 weeks, in my Caltrain rides in the morning for an hour, I've been basically just trying to rework this application, my to-do application, in this pattern that I've used, purely in this controller presenter pattern. So it's a very simple, I'm going to, because this talk is supposed to be only for another 12 more minutes, I'm not going to talk about all the different examples. I'll point you to the GitHub link, and there are like some sufficiently complex examples. It's not as simple as just like create this and just show this. There are some interesting examples going on. I'll talk about that a little later, but right now I just want to show you one specific example. So at least if you go back to the GitHub repository and you see these terms, it makes sense. So this is basically the listing screen. You have a list of to-dos. There are some interesting things happening. So if you see the colors that are being shown, they actually alternate in a very specific fashion. I'll leave that as an exercise for you. When you look at the GitHub repository, it'll make sense, and you'll if you just go through my tests, and that's a huge advantage, it's almost like another form of documentation. So if you actually read the tests, you'll know all the logic that's gone into this application. What I specifically want to show is just this part. So I thought, so my like the objective for why I created this to-do application was like, you know what? There are certain tasks in life that are really trivial, that are like completely nonsensical, but they're essential. So like if I'm at work and I just remembered that, hey, I got to buy milk at, on my way home, like in an hour or 2 hours from now, then I just want to do that. I don't want to create a Google Calendar appointment to remind me of all these things. I just want something stupidly simple that will just get the job done. So I created this to-do application. What you can essentially do is you can quickly add in, you can quickly hit these buttons of different time intervals. And if you see in the due date indicator, the blue thing that's there on top, so the left-hand side basically just formats the due date, but the right-hand side is where something interesting is happening. It basically is like this fuzzy due date difference indicator. So essentially, when I create a task, if it's 12 days from now, I don't really care that it's 12 days from now. All I care is it's about 2 weeks. So essentially, I want that text to tell me it's about 2 weeks. If it's 35 days from now, I don't want to know it's 35 days from now. I want to know it's just like approximately 1 month from now. So that logic, now there might be libraries for it, but for the purpose of like trying this whole pattern, I actually decided to implement it myself. And that's basically what it would happen. So like you create this task, and as you keep fiddling with those time intervals, it'll show you the right text. So I try to like run a whole battle suite of UI tests for this, and I'm going to try to quickly show you one example of that. All right, so this is basically what it looks like in all its beautifully pixelated glory. So like I said, if I thought about this, if I wanted to approach this from the get-go, my presenter is technically the thing that's taking in the ingredients and cooking up this output and presenting it back, right? So I would create something called a task create presenter because it's the task create screen in this specific example. And I would just have 2 methods on it. One would be the get due date text, which is the left-hand side portion of what you see. And I would have another method called get due date difference text, which is the right-hand side portion of what you see. So my presenter would look like this. I'm not actually putting the logic in. If you're curious about the logic, again, you can go back to the GitHub example. But this presenter, essentially, these are the only 2 methods that are there on this presenter. Now, what would a test look like for this? So I took a sample. This is picked out right from the GitHub repository. I've sort of like shortened it to make it look nicer. I took the test where I increase it by 6 hours. So immediately what I do is I create this presenter object and I provide it an ingredient. So what is this ingredient? I've used datetime, which is this library called Core4j. It's the Core4j date library. I wanted to experiment with it, so I use this. I create a date object. I increase it by 6 hours, and I provide it to my presenter. And I make sure that when I get the text back from the presenter, it basically gives me the exact output that I expect. So if it's 6 hours from now, I expect this date to show on the left-hand side. And on the right-hand side, I expect it to show about 6 hours from now. Now, the beauty with this is just one test. I went to town on this and added at least 15 examples. And the advantage is because all of these were at the JVM layer, they are super fast to run. So I could get this functionality up and running pretty fast because all my tests ran super fast. And even if I wanted to go back and sort of change the logic, because I realized at a certain point, most date libraries don't do weeks really well. They do hours, days, months, years, but they don't really do weeks well. And so I had to change my logic. Now, if this was a production application without tests, that would make me just a little nervous because I would have to run through this whole process of trying different things. But because I had the tests, it made it super easy. To give you a little more context, so this is the task create screen. So I used a fragment in the example. I have an on-click listener. This is basically what the on-click listener looks like. Immediately as I get the action, I have a task create controller. I ship the due date of. I'm going to basically just blaze through this because you can actually look at it, and I want to leave some time for questions because I think that's where you can pose some interesting questions and make things, the interesting stuff could come up there. This is the logic on my on-click listener. I have a task create controller. This is what I have a method called change due date in my task create controller. I do the same, almost the same things that I've done in my test. So I sort of like, after having written the test, I just go back and sort of like try to build the real world stuff into this controller. From the task create controller, I have something called a task create presenter. And this is something I've independently tested. So I know this works. I have the task create presenter. I send it the inputs. I get the output back. Again, in this case, I say I talk to task create screen, which is my view interface. I send the outputs to this object. It sends it back to the fragment, which in turn implements this view interface. Now, I know I'm going through this pretty fast because I think all of this is like, once you look at the examples, it gets pretty straightforward. All right, so here's the deal. I did this over 2 weeks, which means it's not like the whole application is not complete. I've not ported the thing that I have like that I've been using for 6 months, but I'm in the process. It's about 40% complete, but I still think there was some super interesting examples. For example, if you've heard the podcast, you know I'm a big believer in RxJava. So I've actually used RxJava and SQLite to sort of like query the tasks and show them up. And I've still managed to use them at the UI testing layer. So I use a couple of these tricks that are known in RxJava where you can sort of force the scheduler to only run on one thread. And so everything still runs on the JVM, but it's again very testable. So there's one example. If you saw there was like one horizontal line in the task list, I wanted also like an indicator like in my tasks to show when today was. So that's also a mildly complicated example. So I have a whole bunch of these in the repository. I've not released it just yet because it's for 40% complete. But for those of you who have attended, I'm pretty sure no one else would know about this. So just send me a tweet and give me your GitHub username and I'll open it up to you. And hopefully in a month or two, once it's done, I'll release it to the public. I think there are some really interesting patterns in here. So definitely take a look and I think you'll find it interesting. Now, I thought it would be easy if I just give you the questions instead of you asking the questions. And this is also a kind of conclusion. I'm just kidding, but I just wanted to like bring up some quick points. So people have said, when I've talked to different people, they're like, well, this sounds like a lot of work. Would you really use this? I totally would really use it if I could. But again, you have to understand, if you're going to an application that has like a huge legacy code base, it becomes a little tricky because it means you'll have to refactor everything. And if you don't have tests in the same place, then refactoring it might make it a little tricky. So that's obviously a caveat. But if you're developing new features, because it doesn't use any external library, it doesn't use anything fancy, it's just pure Java classes, any new features that you develop, you should sort of maybe try to experiment with this pattern. The other question is, well, okay, so do you need to use Espresso? Like, I mean, you have your testing at the UI. I believe you really have to use Espresso, and this is where the concept of an integration test comes in. You have independently tested that your presenter works. You have independently tested that your controller works, right? But you have to have at least one test that sort of runs through the cases and wires it all up. So for that, Espresso helps. The advantage, though, is that you can, instead of having 500 or 200 Espresso tests, you can like ship all of that to much faster running JVM tests, and you can have maybe 2 or 3 Espresso tests that runs through the whole loop to make sure you have at least wired things properly well. So that is again something that's there in the GitHub example. Have a look at it. If you have any questions, you can shoot that. Data binding is another important thing because Martin Fowler basically talks about supervising controller and passive view. And the primary difference between these two is in one, he says, if you have the power of data binding, just use it. I mean, like certain things are so trivial, you don't need to really be worrying about it. And I'm a little reserved about it, but if you have questions and want to know like my opinions on it, you can go ahead. The next point is some things are just internally very hard to test. Like for example, if you want to test the life cycle per se, if that's something that you really want to test, doing it with unit tests is pretty hard. You can technically like have what are called state factories. It's basically you would, at every event that you get, like, okay, on resumed, on pause, on all of these different actions, you could just simply mock these things out. So that's one way you can do it. I'm not a big fan, but well, that's it. And I've mentioned this last point. So this is it. If you have any questions, I can take it. I don't think I have too much time. Let's maybe take 2 or 3 questions. Yeah. Yes. Right. Okay, so the gist of the question is, well, if you really want to do stuff on the JVM, RoboElectric actually helps you do things with the activities. Now, I think RoboElectric is amazing in running the JVM tests, and I've heard really good things about the latest version of RoboElectric 3. Yeah, the only difference is, the only problem I've personally felt is RoboElectric is not officially given its Google isn't officially given its blessing, and because it always trails back, because you have to have like shadow implementations, it's a little tricky. And the other thing is, I had a very rocky start with RoboElectric in the initial days. Setting it up was a nightmare. It isn't easy. I've heard that it's much better now, but I don't use it anymore. I know Corey out here is an expert. She uses RoboElectric. So if you have any specific questions, you can ask her. But in any case, that's my opinion. I think maybe RoboElectric 3 has a place, but yeah, I mean, that's, yeah. I guess, yeah, I mean, that makes sense. The gist of, yeah, that's the gist of it. Are there any questions? Yes, question. Yeah. So the question was, okay, you're testing individual components. Do you use anything like Mockito? I absolutely use Mockito. I use the hell out of Mockito. I mean, there are different ways. Like, there's like you can, if you see the code base, like it'll make sense. Like I use like the verify. I make sure. In fact, the UI flow, the regression, because a lot of this is UI testing. So in my controller, it's the controller that's orchestrating all of these actions, right? So I make sure that it actually orchestrates it. So at this point, does it actually call the presenter? At this point, does it actually call a service object? After getting these results, does it call back to the interface? All those things have to be tested because you're not really doing UI testing if you don't test those things. And for those, I absolutely use Mockito. Alrighty. Any other questions? Okay, so we are, okay, so I think we're out of time at this point. If you have any questions, I'm going to stick around. So please feel free to ask your questions. Thank you so much.